So I have just a few slides and then I'll show you a quick demo. So I'm planning to spend about 30 minutes. So thank you very much for joining. My name's Cottrell, of course, and I work for GridGain. So I'll go ahead and start. And so here's what I plan to talk about. So I'll talk about the reasons why you would want to consider using Ignite and Drools. I'll talk about some reference architectures, and then I'll show a quick demo. So I do want this to be interactive. So if you have quick questions, by all means, ask them during the slides. Okay, so just I think many of you are probably familiar with the architectural trend going on now, where you want to combine the worlds of transaction processing and analytics. And so some of the buzzwords that you're hearing analysts, like Gartner and others use now are things like data integration hub, hybrid transaction analytical platform, hybrid operational analytical platform. So a whole bunch of acronyms with 3 letters or 4 letters. So the gist, of course, is that, Apache Ignite is very much about this phenomenon as well, that it presents a single place where you can do transaction processing and analytical processing. So you may be wondering, well, what does rules, what does business rules have to do with, this kind of architecture? And so primarily, a lot of the interest in using a package like Drools is so that you can do data enrichment and data transformation. And so I have this highlighted in red here just to show that's kind of the angle that I'm going to be taking, is that with Ignite, you can run business rules within the data partitions themselves, that you don't have to do it just in a client orchestration layer. You can actually do it within the data nodes themselves. And so it's a very interesting approach. So why Ignite and Drools in particular? There's a lot of good business rules processing systems out there. And so why Drools? Well, one reason, of course, is that both Ignite and Drools are open source, and so you can download them and experiment quite a bit with them and then build some useful applications. Drools is easily embedded within out-of-the-box features of Ignite, the compute grid, the service grid, the data grid, so you don't have to make any custom extensions to Ignite in order to integrate it with Drool. You can use existing compute grid features. And so given that it's a very flexible distribution mechanism, I like to call it on demand, where we're just using plain old Ignite runnables. So you can use an Ignite runnable and then pass it out to as many data nodes, it can be 4, it can be 400, in order to run rules to do data transformations. In addition, Drools is very Java-centric, that it is also a Java-based rules product. It's a more lightweight approach. It's a Java light and a Java-like way to author rules, in that you can write the rules using Java syntax without having to have the complex if-else control code. And so, like, I don't know how many of you are familiar with things like RETE, RETE networks, but that's the kind of tool that Drools is, and it's a very effective way to build an event-based architecture within the nodes in a very flexible manner. So there's a number of different deployment mechanisms. I mean, the Drools files are just plain, they're DRL files or Excel files or others, and so you can distribute them. You don't have to be limited to compiling them and putting them on the data nodes. You can actually put them in central repositories and then pull them out on demand, which is a key feature, because with any kind of business rules capability, you want the people who write the rules to be able to update the rules and then not have to restart Ignite nodes or restart, rebuild, jar files and things like that. You want it to be dynamic. So the Ignite compute grid pulls down rules that are updated from a central repository when you want to run them. So it's a very flexible and agile deployment mechanism. So what are some of the use cases? So there are some forms of data enrichment, and I'm thinking of things like machine learning that are very state-based, that require a lot of context, that are not necessarily something that can be separated. The different stages can't be easily separated within a session. But there's many others. And again, if you think about your typical, an if-else statement that you're using to run your orchestration. So any kind of a statement, any kind of a rule change that can be modeled as a simple condition. And I'm showing an example here that there's a cache object, a GridGain cache object, that it's a customer object where you can take the value of that object at any point in time and say, the purchase amount is greater than 50 and the customer segment that they are assigned to is equal to 3. Let's go ahead and bump up that customer segment. So think of example, if they spend more, these are contrived numbers, of course. I don't think you're going to be doing this for such small amounts, but if you say that this is like 50,000 monetary units and you want to move them from a silver to a gold, for example, that you have a very simple rule here, and it's a very simple way to state how you want that cache entry to be modified. And so lots of businesses, customer segmentation, in the financial world, any kind of asset management, if you're trying to sort packages, by weight and size, or, in the healthcare space, some very well-defined criteria here, like weight, weight and body mass index and others. And so these are the kinds of things that lend themselves to Drools, okay? And so in terms of building the executables, it's a well understood process. So for those of you, I'm assuming most of you or several of you have actually worked with Compute Grid, and so you just use a broadcast statement where you model the runnable. The Ignite runnable includes a lot of the Drools engine. KIE stands for knowledge is everything, and so that's just kind of a general. That's the runtime engine formerly from JBoss that controls business process management, that controls the rules firing and many other things. And so you put these classes within the runnable, you include them. And I would recommend for some of these bigger classes here that you go ahead and just deploy the jars on the nodes rather than try to use pure class loading, because they are large, and then just leave the the transmission piece, the Compute Grid piece to the runnable itself. So that's what that looks like. Building the executables, again, it's a conventional Java development process that you include some of these Maven artifacts within your POM file. You attach to both the Ignite and to the Drools repositories, and then you pull the jar files down as you build the program. If you're using an IDE, like I like to do, I also download a lot of plugins that allow you to create a specialized editor for some of these files, so that it can enforce the semantics and the grammar and things like that for you. And then, of course, there's one big GitHub repository if you guys want to look at dozens of programs to give you some examples. So. All right, so what are some of the architectural considerations? The big one to keep in mind is that there's a trade-off between the ease of software development and the amount of memory you consume. So as you know, with Ignite, that you have off-heap RAM consumption used by the cache objects, and then you have on-heap that's consumed by the Java code. So any of the things that you do, the cache puts, the cache gets, the local processing, all those things take up some heap memory on the node. And in addition, the Drools piece is not necessarily a small heap overhead that it rebuilds for any Ignite cache node. All of those cache entries that are on that node, that whatever needs to be processed by Drools, that another copy needs to be brought into the Drools address space on heap. The Drools is not able to process the Ignite cache objects within the Ignite cache. It has to pull it into its own what's called an agenda session. And so imagine this scenario. All of the objects in the when clause, the customer, the order, and the order detail, that they all, there's like a multiplication that needs to be done in order to do the processing. So if you don't have any of the predicates here, if you pull in all of the customer objects, all of the order objects, and all of the order detail objects, you're doing a product all of them. And so 1,000 customers times 10,000 orders times 100 order details per order is going to be a very large number, and you can run out of heap space. And so it's very important that you do these predicates here. And so there's a very rich and powerful predicate language. It took me a lot of trial and error to manage, but essentially what you want to do is the more joins you can do within the when clause, then you're actually limiting the amount of the number of objects that needs to be placed into the agenda, and then you're minimizing the amount of extra heap that the Drools piece takes. So again, it's the trade-off that you use more memory for those nodes where you want to run Drools within Ignite. You need to have more heap space, but the trade-off you're getting is that it's easier to do the data transformations, that it's more dynamic, and that you place more of the data transformation logic into the hands of the of non programmers. Okay, so I hope that makes sense. So here's one graphic that I was going to show you here. So this is kind of a one diagram. So at the bottom here, of course, you have a very standard Ignite architecture, right? That you have the this transactional persistence or native persistence is of course optional. I mean, you can do this either with a relational database or with our own native persistence. But of course, the heap and the off heap are something that are common to all Ignite deployments. So you have your cache here in the off heap. This is where the cache is put. And then in the on heap, you have any client related code, any cache manipulation code. But then this is where you also place the Drools runtime system in the objects when you are performing the compute task. So you do the compute, the broadcast, and when you put the Ignite runnables with Drools, and this could be several statements here, you can do this many times, depending on what rules you want to fire. And so these will also consume memory. And so this is dynamic, and it's effective as far as the process orchestration is concerned, but it is also something that you need to account for when you're dealing with memory. Now here is a system, this approach I think is a lot more interesting for those of us who are interested in agility, that the real payback with using business rules like Drools or with any rule system that can be embedded within Ignite runnables is the fact that it can be updated externally to the deployment. And so this is what the code looks like, that within the runnable itself, that you clear basically this KFS here, that the KIE stands for knowledge, that's the buzzword for the Drools runtime. And so this is an in-memory file system where the rules are stored. After the rules are inputted, they are automatically compiled into Java classes. And so that might be acceptable behavior for rules that don't change much, but if you want rules that change a lot, it's actually fairly straightforward, where you have your pointer here to the external file directory, but then before you load those, you clear out the in-memory within key, and this KFS is a different memory space than Ignite cache. Okay, so you're clearing out the rules logic within the space here, and then you're repopulating it with whatever is the most current file content here. So I'm showing you a very simple example, just on my local box here, but this would point to something like a GitHub or a version control system or some kind of a shared file system. And this unit here, this storage is just an external drive that the runnable pulls in on demand, so that when these Drools rules are loaded here, they are updated with the most current logic, okay? And then of course, for this external rules repository, if you're in the the JBPM world, you might be using Business Central, but any rules repository where you have different users that are populating this, and then when the Ignite client runs, and it's just pulling down the latest copy and then making sure that you have the most current rules. Okay, that's and then for future consideration, maybe it's a future time, just to kind of take it a step up, that a lot of people are interested in using Ignite. I've done work not only igniting integrating Ignite with Drools, but I've also done some work igniting it with a BPM system. So in particular, again, from the open source world, the JBPM product. And so here's the general approach I would use. So on the right-hand side here, you see pretty much the same as what I showed you earlier, that you have caches, and then you might have some Ignite runnables that are downloaded to process the cache. And then I'll show you some of this in a quick demo I put together. But in addition, you might wrap the Ignite client that is doing all of the, both the cache operations, the cache puts and gets, as well as any of these Drools, these Ignite runnable calls, that you wrap them with some kind of a service object here, and you have some well-defined methods, and then you call the methods from your BPM layer. And then in that way, you can have we normally talk about Ignite servers as cache servers, but you can also have Ignite clients that are wrapped with some sort of a service object. This can be a service grid, it can be a REST service, anything you choose. And then you can have the Ignite client also be an object server, like a data server that intermediates between the process layer and the cache layer, and then all the while is making use of this external repository that is being supplied with updated rules by the business analyst. Okay, so that's it for the slide deck. Let me show you, let's see. I guess I need to share my IDE. So let me try resharing my share. And so this, can you guys see this okay?
Can you please make maybe font a little bit bigger, if it's possible?
Gosh, I don't know if I could do that with Eclipse. Yeah, sorry about that. I didn't think about the font. I don't know if there's any other kind of a zoom feature here. Yeah, sorry about that. Can you guys, if I go slowly, can you kind of make out what you guys are seeing here? I don't know of any way to, let me do a quick search here. Zoom, I apologize, I didn't think of that.
It's better now, really.
Yeah, maybe something easy. All right, yeah. Control, let me try this. Hopefully I don't break anything. So Control plus, see what happens. Nope, I don't see anything going on here. Oh, there you go, look, it worked. You see that?
Yes.
I have never used that feature before. Ksenia, you are an expander of consciousness in the world of software development. Okay. All right. Well, anyway, so here is so here are the I might have to pull this down a little bit to so here's a sample project that that I put together. So I have two servers, which I'm already running, and then I have a client here that I use just to populate the cache, and then this is where I actually run the rules. And so the two servers, and I'm running these with all within Eclipse here, just it makes it easier to see. So I'm running a couple of instances here that are just they're just cache servers is all they are. So I've started them up, and then my client program, which ran and then terminated, that you see here, it simply populates, I create some random numbers. And so I'm using a random number generator, and what I'm creating is a key value. I'm creating a random name, and then I'm creating a random purchase amount, purchase history, and then I'm assigning everybody to 0. Okay, so when I run that, I get something like this. And so when you look at the output here, you can see this data is inconsistent, because somebody who spends, $94, I mean, I have a range of 0 to 100. Somebody who spends $94 should not be in customer segment 0, just like somebody who spends, less than $1, this 0.6 here. And so this is this data is not correct. And so what I need to do is I need to normalize this data. And this is how I'm going to normalize it. So I have a spreadsheet here. And so this spreadsheet is a handy way to kind of collect, instead of having individual DRL files here. So this is what a DRL file looks like. And so you notice that the keywords here that they're highlighted. And so this is a benefit of having the Eclipse Drools editor, is that it helps you to build, to use the right format for the rules here. And so the rules, that there's a rule name, there's a when clause, and then there's a then clause, which is what does the action, that this is what is used to update the caches. Okay, so a somewhat easier way to organize the rules is to put them in a spreadsheet. And so you see a lot of the same, kind of statements here. And so these are the conditions where everything that is a customer entry is pulled in. This spreadsheet is run within all of the nodes here. So this is a local entry that is done within each of, 2 nodes or 200 nodes. It's up to you. And then these are the amount ranges. So think of these as the separate rules here. And then if you're 0 to 10, I do segment 0, 50 to 75, I do segment 3, so on and so forth. So this is a shorthand way to write what those DRL files do, and it's just a way to kind of collect things together. Okay, so that's the rules file. And then this is what the Drools engine looks like. So this is my Ignite runnable here. And so I implement the run method, of course, and then these are all of the calls that I make. So I have to import all of the Ignite cache stuff, and I have to import all of the Drools runtime engine. And so, like I said, these are things that you want to, for the most part, you want to put them into the jar file at the node. But you can stream this Ignite runnable, and this is where I don't have the dynamic update capability here. I mean, I could show you what that looks like in another project. But basically here, these are all the local entries that so you see the cache local entries. So this is running within the node here. So however many nodes you run, you will all run the local entries. I'm getting the value here, and then I'm doing an insert into the Drools agenda space here. And so this is why you're taking memory, you're doubling the amount of memory you take by using the Drools engine. And so this is the trade-off I mentioned. I am firing all the rules here. Normally, with an actual application, you would want to segment the rules in such a way that you're firing rules at a time, and then orchestrating some, and then firing some more rules. And so you're trying to manage the number of rules that you're loading into memory at any one time. Then, of course, this last statement here stops the session and clears the RAM from the heap so that it's ready for some future action. Okay. So here is where, by the way, these are the the POJO objects. So again, you're just using regular POJO objects here as your cache entries, and then this is what I think I already showed you. This is the one that's streamed out, and then this is the client here that sends it out. And so all I do, I'm just doing this is where I make the call here, and I am calling the broadcast that sends this object out to all of the nodes. Okay, so I'm going to go ahead and run that now. So let me run that. And then this is going to run to completion. So it's just going to do the update. It's going to fire the rules, process the caches, and then stop. It's going to exit. So I think my system might, of course, I think it kind of slows down when I'm doing demos here. So there we go. So here's the output. So you remember, so I'm printing. So this is where I ran. And so it's printing out. So when I'm done running it, I print out what it looks like after I've normalized it. And so now all of the segments should match the spend amount, right? And so if you look at each of these, if you're like 75 and over, you should be in 4. If you're, less than 10, you should be 0. So all of these have been normalized. And then when we look at what happened at each of the nodes here, we'll see that things were processed. So I was actually calling rules at each of the nodes. So here, I'm looking at these keys here. So this is where I'm calling. So I'm printing these out here. So first of all, I am printing. So this insert statement, this is run within each of the two nodes. So these are the keys here that I'm running, and I'm inserting that key into its own local copy. And then this is where I'm calling the rule. If you look at the rules file here, the spreadsheet, I have a printout statement here. And again, let me resize all these. And so if you look at this print statement, this is the action here. See, where is the, oh, here. So this is the printout. So you see this system printout. So this is all Java code that's executed. So I'm printing the segment. So I'm resetting the segment to the proper value, okay, which is anywhere between 1 and 4. So these are all the printout statements that are being run from this spreadsheet within the node. And then when you look at the printed output for each of the nodes here, let me just, so this is one node here. And so you see these entries, and then if you go to the other node, you should see different keys processed there. And so you see these keys. So I assume you see that. So that's really it as far as the demo. I mean, so now I guess, Ksenia, you want me to go into some Q&A? Is that? Okay.
Yes, sure. Can you please?
Oh, I need to stop sharing. So let me get back to the screen.
Can you please share the link on demo? Because I know that you have a demo in the repository.
I need to put it there. So okay. Let me. Yeah.
So I will post it along with the video in that case.
Okay.
I see that we have a question in the chat. Can you run a streaming fashion as we ingest events from Kafka? Yeah, we can. So we have a we have a certified Kafka adapter, certified by Confluent, that's available. If you get the GridGain product, it's available as an actual supported product. If you use Ignite, of course, it's an unsupported product and it doesn't have all of the features. But from there is a data streamer object that we recommend you use. And so what the data streamer does is that it batches all of the cache puts into larger groups of puts. And so it's much faster at loading data from Kafka. So it's an optimized version of the cache put that it batches a bunch of the cache puts together. And so take a look at the data streaming object. If you can use that with any Kafka adapter, it doesn't have to be Confluent, it could be anybody, yeah.
The question was, can I use this, running the Drools as I ingest the data?
Yeah.
So like in event processing sort of way.
Yeah. Yeah, I mean, they're separate activities. I mean, the Drools is just working on the local entries within the cache node, right? So it doesn't matter how the cache entries get there, whether you're using data streamer or whether you're using cache puts. And so once the cache objects are in the node as local entries, then you can use Drools to process. You need to share the object schema. You can either use binary objects or you can use POJOs, as I've done. And then once you do that, you can use Drools for anything.
Yeah, I mean, in the sense that once an entry is entered, immediately get an event or get it to run the rules immediately, not as a secondary process afterwards and run those you demonstrate. Yeah. I mean, I'd have to think about that. I mean, I guess my main concern would be one of performance. Okay. That it's fine and good to use events, to trigger the Drool system. And so, for example, you could deploy Drools in a service grid fashion, for example, right? So with service grid, you put it as a process that runs in the execute method for service grid, but then you would still have to use some kind of a polling architecture. I don't think that you would want to be triggering a Drools run every time that you do a cache event, because that might put a big load on the system. So I think you would need to be careful about how you orchestrate that process within the node.
But yeah, I mean, there's no theoretical reason why you couldn't do that if you want.
Okay, thanks.
Yeah, my pleasure.
So as you see, unmute and ask by voice will be a little bit faster than chat. So take a chance. And Ken, if someone will have question after the event, what channel would you prefer to be on?
I think I see another question here.
Please read it loud.
Oh, okay, yeah, from Manuel Pereira. So I am very excited about your presentation. Congrats, I loved it a lot. Very good. Yeah, I'll always share questions like that, Ksenia. And then, so the question, since 2018, we use an Ignite plus Drools integration approach to implement our new digital service and marketing virtual assistant platform based on a CEP paradigm, complex event processing in my organization. Our microservices are written using DRL and executed as Ignite services. We process in production about 1.2 petabytes of events data. Yes, petabytes. So our approach to use Ignite Drools was a bit different. Just saw some more advanced use of Drools, rules only, not BPM yet, and Ignite. For example, our microservice Ignite service integrates multi-case session threads that are continuously execute the events that are obtained from the event stream transport layer in our case. That approach allows us to fine tune the ability of throughput, the rule evaluation, separates it from the general processing of a work. So that's more of a statement of what they're doing. So thank you for sharing that. Manuel, if you don't mind my asking, when you talk about a service, an Ignite service, are you talking about encapsulating that within like a service grid, or are you using that in the more general sense of something you're running within a node? If you don't mind my asking. Yeah, Ksenia, I guess I'm not supposed to ask questions back, huh? But, maybe we can take that offline. I'm just curious how you're doing the how you're defining the Ignite service. All right. Well, maybe we can talk about that later. If you know, Manuel, I'd be happy to put my email address if you want to ping me, and we can chat some more. Do you mind if I do that, Ksenia, or do you prefer to put my email in a separate?
If you don't mind, we can put that at the end of the slides, for example.
Okay, yeah, that's fine. That's fine. Okay.